we learn what matter is. We came to know that matter is made up of particles. Today, let us try to know how the particles of matter behave. The particles of matter, they have some unique features. Let us know one by one. First thing is, if you take a matter, the particles of matter are so tiny, so small that they can occupy the interstitial spaces. The second point is, the particles of matter, they are in continuous motion as they possess kinetic energy. And the third one is, the particles of matter, they have capability to attract each other. That we are going to study about all these things in detail in our practical classes. Now, let us come to the states of matter. You have already studied about the states of matter. You know that there are three states of matter: solids, liquids and gases. How they are classified? They are classified based on the arrangement of particles. Now, the first one is solids. So what are solids? In our day-to-day life, we see many solid objects. Solids are those which are hard, which we can touch and which we can feel like that. If you take a solid is having a definite shape. It is having a distinct boundary, and then it has low compressibility. A solid cannot change its shape even by applying force, but it can be broken. If you apply a large force on a solid, it will break up, but it cannot change its shape. So this is called rigidity. A solid is rigid. It can retain its shape even by the application of force on it. That means it has low compressibility. It cannot be compressed. The compression is very negligible. But when you come to the other examples like rubber. So rubber, when you apply force on a rubber, it will change its shape. When you release the force, it will retain its shape. That means it comes to its original shape. And if you take a sponge and if you press the sponge, it will get compressed. Do you mean that rubber and then sponge-like substances are not solid? No, they are also solid. Second state of matter is liquids. So liquids are, unlike that of the solids, they do not have definite shape. They take the shape of the container. See, whatever container you pour a liquid, it will take that particular shape. But liquids have definite volume. So take for example water. So water, it has the property of flowing from one place to other. So why the liquids flow? So because the force of attraction between any two particles in a liquid is very weak when compared to that of the solids. So therefore, liquids have the property of fluidity and therefore they are called fluids, but whereas solids are called rigid. Now, if you take water, so water can dissolve in itself so many gases because it has the property of diffusing many substances into it. That means we can conclude that in liquids, solids, gases and liquids can diffuse, whereas in solids the rate of diffusion is comparatively lower than that of the liquids. It is because due to the arrangement of particles, where in liquid the particles are set apart. So therefore, due to the weak force of attraction, they have the ability or they have the property to flow from one place to the other. So this is with regard to the liquid. The third state of matter is gas. Somebody may ask you a question: have you seen oxygen? Have you seen carbon dioxide, nitrogen, like that? We cannot see gases. Gases are invisible, but they exist in nature. It is one of the states of matter. Why they are invisible? Unlike that of the solids and liquids, in gases there is no force of attraction between any two particles. The particles in a gas, they are free and then they move randomly. So therefore, they cannot be visible to our naked eye. But if you take gas, A gas is highly compressible. You might have seen the LPG cylinders or CNG cylinders in our home. So where the gases are compressed at a high pressure, or in the hospitals you might have seen the oxygen cylinders where oxygen gas is compressed highly under a cylinder, within a cylinder. This shows that gases have high compressibility. The pressure exerted by the gas on the wall of the container is nothing but the particles of the gas, they hit against the wall of the container, which is nothing but the pressure of that particular gas.